law of triangle, law of polygon, resolution of forces, sin theta, cos theta. We can move further with the next topic, which is free body diagram. Free body and free body diagram. This is a very important concept in solving force systems. Some particle or some body, when it is subjected to many forces, suppose it is a part of a machine, suppose it is a part of a car, or it is a part of a structure, then every time for solving you need to draw the structure and locate the points where actual forces are being acting, and then to resolve them and solve them. So easier way is to remove the structure or the part and consider it as a particle or a body on which the forces are acting, right? So that concept is known as free body diagram, and the body on which all those forces are acting is called a free body. So free body is what? That on which the forces are acting as well as the reactions. Now comes a new term which is called reaction. What is a reaction? કોઈ ન્યૂટનનો રેફરન્સ છે આમાં રિએક્શનમાં? થર્ડ લો, Newton's third law of motion, action and reactions are equal and opposite. It means that whenever there will be action, there will be a reaction. So the reaction in this definition refers to that reaction. Suppose there is a ball, this ball. Now we will be talking about bodies in equilibrium, because in MOS subject we are dealing with statics. We don't have to deal with when the ball is falling from h1 height to h2 height. Our ball is on rest. Okay, so what is the force which is acting on this ball? Suppose mass is m. Correct? It is acting on this. It means that if I drop the ball, why it is moving towards downward direction is because of some force is constantly acting on it. As Newton એ કીધેલું સફરજનના કેસમાં, આપણે બોલના કેસમાં. ઓકે, સો આ વસ્તુ છે એનો ફ્રી બોડી ડાયાગ્રામ શું થશે? રાઈટ, પણ આ અત્યારે મોશનમાં છે, મેં પકડી નથી. હવે ધારો કે હું આ ટેબલ પર બોલને મૂકું છું. This is a table. Now what are the forces acting on the ball? I have just kept the ball. This is a table and I have kept this ball on the table, which means that now ball is not going to fall down. It means that table is doing something. This is only W is equal to mg. The moment I drop it, it falls down. Why it falls down? Because we know that F is equal to mg, mass into gravitational acceleration, 9.8 meter per second square. Now my body is in equilibrium. It means that it is not falling, it is not showing any movement or motion. So this is, normal people will say it's a steady ball. We will say it is in equilibrium. Equilibrium means all the forces acting on this body are summation of total forces. That is the reason ball is at steady position. The moment the forces are imbalanced, it will move in the direction of the force. Now, what are the forces acting on this ball? Gravitation force तो है, એ તો જવાનો જ નથી. અને બીજો કયો છે કે જેને લીધે અહીં ટકી રહ્યો છે? નો ફ્રિક્શન. હાથ જે ફોર્સ આપે છે તે. પણ હાથ શું ફોર્સ આપે છે? તો કઈ ફોર્સ નથી આપતો, કે આપે છે? જેટલો આને નીચે લઈ જવા માટે ફોર્સ લાગે છે ग्रेविटेशन નો, એટલો જ માર લગાડવો પડે છે. हम सबको ये पता है. सेम चीज होती है जब आप बाल्टी उठाते हैं. अगर आपने बाल्टी भरी हुई उठा के रखी है for 10 seconds 20 seconds we are fine, just lift it for 1 minute and then you realize what is the force you have to constantly provide not to fall that balti. समझ रहे हैं? That is reaction. Action is this, and when you are reacting that, when you are opposing that force, because you want to keep this in equilibrium, so whatever is the final force acting on this material or body or particle, you have to resist that force, for which you are providing a resistance, a reaction. It means that W is equal to mg is acting on it, you are also providing W is equal to mg. My hand mechanism is providing W is equal to mg on opposite direction to keep it balanced, to keep it in equilibrium. So free body diagram of this mechanism is now R is my reaction. સમજાય છે? આ તો સિમ્પલેસ્ટ પ્રોબ્લેમ છે. તો બી સપોઝ ઇમેજિન કરો કે અત્યારે આપણે આ સોલ્વ કરવું હોય, ઘૂસી જા ફટાફટ, અહીં બેસ જા. તો drawing this is simpler or drawing this is simpler? Because in this drawing, this ball or diameter of ball or actual mass of ball, material of ball, size of ball, size of the table, આ તો મેં જેમ સરફેસ બતાવ્યું આમ ટેબલ પણ ડ્રો કરી શક્યો. That doesn't make any difference for calculation of forces. We can consider this entire system or body as a point on which the forces are acting. કારણ કે આપણને ખબર, we can easily imagine that when this is the ball, the W is equal to mg is acting, it's not acting on this surface or this surface, but it would be acting at the CG of the ball, center of gravity of the ball. The reaction will be also be on the opposite direction of that point. So that point is, so the entire body is represented by a point, or at least by a free body diagram, free body. That is the concept. Now suppose same thing, same ball, table, right? Now someone is pulling this ball this side, આખું મોટું ટેબલ છે, and someone is pulling this ball from this side. It will have some force. એનો મતલબ કે એ ફોર્સ જેવો લાગશે તો આમાં તો બેલેન્સ થઈ ગયું. W બારી ખુલ્લી છે. ઓકે, so W and mg and reaction balance થઈ ગયું, પણ horizontal direction માં if there is a force and you want to keep this in equilibrium, then you will have to apply similar force. So if this is acting at some force and now I don't want this ball to move in this direction, what can I do? I can generate any mechanism which will stop its motion in this direction. One is, I'll construct a wall here, provide a hook and tie that hook with the string to the ball. Another thing, I'll just call some person, can pakdi rakh. All those things are just to not allow this ball to move in the direction of force, which is again reaction. Suppose I'm constructing a wall. I'm constructing a wall on which there is a hook to which the string is attached or a rod is attached. Now when someone is pulling in this side, but this will not allow it to move, the free body diagram will be F1 reaction due to wall. Cover padhe se? Yes. Okay. Now suppose this is wall, this is my ball and it is attached here. This is the center. This is the string. This is ball. Is this in equilibrium? It will remain in equilibrium. Now tell me, what are the forces which are involved in this equilibrium force system? Let us consider this as a free body. First is આ તો લાગવાનું જ છે. Okay, then okay, then so tension in string which is resisting this ball not to fall. જે પહેલા ટેબલ કરતું હતું એ જ વસ્તુ દોરી કરે છે, પણ દોરીમાં ટેન્શન જનરેટ થશે અને કઈ ડાયરેક્શન? આ ડાયરેક્શન. હજી હજી કઈક છે? વોલનું હા એ કયો છે? વોલનું રિએક્શન. કારણ કે વોલ આ બોલને આમ નથી આવવા દેતી. સમજાય છે? જેમ આ સ્ટ્રિંગ બોલને નીચે નથી જવા દેતી, સિમિલરલી પગ નીચે. નોટબુક ક્યાં છે? Similarly, the wall is not allowing the ball to move in this direction. So wall is providing some resistance in this direction, which is reaction of wall. समझ में आ रहा है? This is called free body diagram of this system which is in equilibrium. So instead of drawing this thing every time and resolving forces here, it is convenient to go for a free body diagram. यहाँ पे कम फोर्स है तो ये ड्रॉ करो, ये सिमिलर होता है. लेकिन when there is it is a part of a machinery, some part or partial portion of a machine or a structure, it is very convenient to go for a free body diagram in which you consider entire body as a particle and exhibit all the forces which are being acting. So now you can understand easily that if I tell you that calculate tension in string, calculate tension in string. Can you calculate? Yes. This is just what? Resolution of forces. આવડે? ઓકે. હજી એકાદ એક્ઝામ્પલ જોઈએ ફ્રી બોડી ડાયાગ્રામ. Ball A, ball B. You can imagine what this is. Some resisting surface on which there is one ball which is fixed, which is stuck here. It's in equilibrium, no motion. Another ball which is a bigger one, also here, stuck here, no motion. It means that this entire system which is in equilibrium, there are forces acting on it. And here we have two bodies. One is ball number A, second is ball number B. So you have to consider this as a free body, this also as a free body. So this will have two free body diagrams. पहला જોઈએ B પર કયો free body diagram છે? B પર કયા forces લાગે છે? આ તો છે જ યુનિવર્સલ. પછી આ wall નું reaction of wall. આ wall નું reaction R wall dash અને correct reaction from this also. So reaction due to A on B. This is the complete free body diagram of this ball. Any person who has not studied this subject, તમે એને પૂછો કે આ this is very simple thing to imagine કે આમાં શું बॉल पर कितने फोर्स लग रहे हैं, कुछ नहीं हो रहा, लेकिन नाउ वी नो दैट टू मेक दिस सिस्टम इक्विलिब्रियम there are number of things which are playing a role. Any one of this varies, the system may go out of equilibrium. समझाए છે? Now free body diagram of A. mg આ તો આવવાનું જ છે સેમ જે આમાં છે તે. સમજી ગયા તમે? એ આજે આર એ બી થયું, એ અહીંયા આર બી એ થશે, they will be same. ના કીધું એને, કારણ કે બે બોડી અલગ છે, બોડી જ બે છે, કારણ કે બંને પર ફોર્સિસ અલગ અલગ લાગે છે. આની પર લાગતા ફોર્સિસ આના સીજી ના રેફરન્સમાં છે, આની પર લાગતા ફોર્સિસ આના સીજી માં રેફરન્સ છે, અને બંને એકબીજા કનેક્ટેડ છે, એને લીધે આ ફોર્સ તમારો આવે છે સરખો. આ નીકળી જતે ને. ત્યારે આની વેલ્યુ બદલાઈ જશે ને. Correct, nice question. He is asking that if there is no A ball, then also this system can remain in equilibrium. That is true. A ball is not introduced to keep this in equilibrium. A ball was already there. This is a system given to us. We cannot change. હું તમને કહું કે આ સ્ટ્રક્ચર છે, એમાં બે બીમ છે ને કોલમ છે, તમે એમ કહો જરૂર નથી એક બીમ કાઢ નાખો, ઓલરેડી સ્ટ્રક્ચરમાં છે, તમારે એનાલાઇઝ કરવાનું છે. એક આન્સર એનો એ છે કે we are already given the system, we have to see free body diagrams and the forces for equilibrium. Suppose now as a modification, if we can remove this ball, we want to see whether the system will be in equilibrium or not. It will be in equilibrium, we can easily imagine that, but in that case the value of rw r wall and this r wall will change, because then it is only this wall's responsibility to keep this ball here. Right now this is also sharing some responsibility to keep this ball here. So આના પર રિએક્શન શું આવશે સમજ્યા? સપોઝ અહીંયા હું ત્રીજો બોલ મૂકી દઉં તો આના બી તીન ટુકડા રિએક્શન આવશે અહીંયા, એટલે આ લોકોમાંથી થોડા ઓછા થશે, but system will remain in equilibrium. So all the forces acting on system will summarize to zero in x direction and in y direction. Clear sir? કોન્ટેક્ટ જોવાની એની પર જેટલી પણ વસ્તુને લીધે ફોર્સ લાગતા હોય, સપોઝ આ બોલ આમ હોત તો આને આની સાથે કોઈ લેવા દેવા જ નથી, પણ આને આની સાથે છે. very easy, we will start solving problems. or ચાલો એકાદ જોઈએ જ, બુકમાં કેવું છે તો જોઈએ. અરે યાર કયું પેજ હતું? આ બોલ વાળું એક્ઝામ્પલ જ હતું બુકમાં. Have you seen this type of structure? This is called this is called તમને ખબર છે? This is called a truss. This type of structure all of us have seen. This is mostly made up of steel or somewhere wooden. If you go to Himachal and all those northeastern states of India, you might see wooden also, but it will be small. But the large ones upon which the traffic is passing, you will see this type of structure, which is a truss. Let us consider this very small portion to these two members of a truss. There will be reaction એમના નથી જતો. એ suppose આ એક member છે, this member, and this is the member. Write down. હું તમને exact value કહું એટલે તમને solve કરવાની મજા આવશે. Suppose in some practical problem, we have to calculate what are the forces in these two members of the truss. The other external forces are given. So first we will draw a free body diagram. Certainly, what will be the free body diagram of this point? 12 kilonewton, 8 kilonewton, which will be having angle 45. Then this is unknown P1, this is unknown P2. P1, P2, this angle is given 30 degrees. So this is the free body diagram of this system, which is in equilibrium. You know that the truss is in equilibrium. તો જે ત્યાંનું ત્યાં છે ને, અધરવાઇઝ તો ગાડી જાય તો એની સાથે ટ્રસ આગળ જતું રહેશે. Okay, so this is in equilibrium. It means that after drawing the free body diagram, this we can see this very clear that okay, now we don't need to do anything, just resolve the forces. How resolve the forces? Here we are not calculating resultant. Once it is said that system is in equilibrium, it means that there is no resultant force. Resultant force is system is in equilibrium. It means that all the forces which are acting on that system are balancing each other. So system is in equilibrium means that summation of H equals to summation of V equals to 0. So all the forces in X direction, all the forces in Y direction are 0. Then and then the system can remain in equilibrium. Now it is simple. Take all the cos components equate to 0. Take sine components equate to 0. You will get P1 value, P2 value. Clear? This example I am just showing to show the importance of this concept, free body diagram, and why we are required to do such things, because we want to design truss or beams and all those structural elements. Again, मैं अगला क्लास में कहलू, we cannot do trial and error. We cannot just make the beam first and then check whether it will take the load or not. We cannot just make the truss and check now, let us see whether it is taking load or not, it is falling or what, it is breaking or what. We need to calculate first all the things, then make the thing happen. So for calculation, we require that what is the force in this member, what is the force in this member, then to select કે member કેટલો જાડો રાખવાનો છે, મોટો રાખવાનો છે, वो स्टील का सेक्शन है, उसका मोमेंट ऑफ इनर्शिया क्या रखना है, उसका क्रॉस सेक्शन कितना रखना है, विड्थ क्या रखनी है, थिकनेस क्या रखनी है. Because our ultimate aim in structural engineering is to design structure. Analysis is just diagnosis. Okay, just let me, this subject which is mechanics of solids, MOS, right? The starting point of structural engineering. After this subject, there will be another subject in next semester, theory of structure. Theory of structure. So here you are learning about solids, how solids behave. What is their behavior when forces are applied on a solid as a body, as a particle. What are the things happening to it? In next semester, you will start to learn about the same thing with the structures. What are the force? What are the behavior of structures when they are applied with different types of forces? In next to next semester, fourth semester, જે અત્યારે તમારા seniors છે, the subject is basic structural analysis. Basic structural analysis. Then in fifth sem, you will have structural design. So to reach to structural design, you need to pass or travel 3 semesters, 3 subjects of load of 3 subjects to understand the analysis. Analysis and design, I normally give analogy as when you go to a doctor. Suppose you are having fever since 2 days and you go to a doctor. What will doctor tell you? What will he do first? Write you a medicine? No. Then what will he do? Check up. He will ask for symptoms, right? He will ask you the question. तब हम उसको नहीं बोलते कि मुझे क्यों पूछ रहे हो, तुम डॉक्टर हो, पता करो. हम थोड़ी डॉक्टर हैं, मुझे बुखार आ रहा है, तुम पता करो. तो पता करने की ही वो प्रोसीजर है. विल आस्क यू, ओके कितने दिन से बुखार आ रहा है? 2 दिन से. कितना टाइम तक रहता है? फिर गोली लेने से उतर जा रहा है कि अपने आप उतरता है? शाम को ही आता है, सुबह भी आता है? कितना टेम्परेचर जाता है? उसकी क्या प्रोफाइल है? उस वक्त सर सिर में भी दर्द. ही विल कीप ऑन आस्किंग क्वेश्चंस because based on those question answers he will diagnose. What he will diagnose? That okay, the fever is due to this reason. At first stage it was looking like it's a malaria, but it is not malaria, it is something else. So to reach to that conclusion, he need to do an elaborate diagnosis. So in our case, the diagnose part is analysis. What we are doing this, everything, this is diagnose. Take a free body diagram, see the forces acting on it, calculate the forces. All this is diagnose. Why? Because after diagnose, perfect medicine so that he can be relieved. Similarly, in 5th semester, you have to give perfect design for this. And for design, giving design, you need to know kya forces lage. What are the types of beams? What are the types of columns? All those structures we are going to study. That is the reason in very first lecture also I have mentioned that this is the very first subject of this chain of series of subjects. So to reach to the design level, you need to go through these 3 subjects: MOS, theory of structure, basic structural analysis. Right? So this is the importance. Why I am stating the importance? Because this is not only just required or to be remembered for passing in this semester. Once you know this, you know this. You never forget this. This is like 2 + 2 4. जब तुम स्कूल में पहली बार पढ़े थे समेशन, तब वो तुम उसी क्लास के लिए पढ़ रहे थे. ये टीचर ने होमवर्क दिया है, क्लास वर्क दिया है, इतने प्रॉब्लम सॉल्व करने कर दिए थे. लेटर ऑन इन अपकमिंग ईयर्स ऑफ स्कूलिंग आपको रियलाइज हुआ कि ये तो हर साल पूछते ही रहता है, हर चीज में ये तो आता ही रहता है. ये चीज सिमिलरली वैसी है. एक बार आई तो आती ही रहेगी. दिस सब्जेक्ट इज ऑलमोस्ट इंक्लूडेड विद दोज टाइप ऑफ टॉपिक्स ओनली, जो आते ही रहेंगे. एंटायर सब्जेक्ट, जितने भी टॉपिक्स हैं, दिस ओनली वन टॉपिक, रिजोल्यूशन ऑफ फोर्सेस, फंडामेंटल ऑफ स्टैटिक्स, जो हम कर रहे हैं अभी. ओह, अभी तो टाइम है. ओके. આમાં કઈ ડાઉટ છે? Let me give you one more free body diagram so that you can imagine things. This is a system again which is in equilibrium. There are two blocks. Block B is resting on a ground or a table. Block A is resting on block B. Block A is connected through rope to the wall. Block B is connected to a rope and providing force P at 30 degrees. Our job is to draw free body diagram. पहले ये तो ड्रॉ कर दो. Let us first draw free body diagram of A. Free body diagram of block A. What are the forces on block A are acting, which are responsible to keep the block A in equilibrium? Rope wala, suppose tension. B2A 300 ખબર છે આપણને. So this is block B is trying to move in this direction. So friction of this will be relative motion. Imagine, suppose this system is not in equilibrium. Suppose system is not in equilibrium, this will move in this direction. So block A is moving in this direction, so friction of this block A surface will be opposite to the motion. A is moving this direction with reference to B. A will move in this direction, then the block friction will be in opposite direction. Friction 1. Free body diagram of A. Out. Now comes free body diagram of B. Little tricky. So here we cannot draw this B body as a particle. Why? Because in B there are forces which are distance apart. There is not all forces are going through the CG of B. All the forces acting on B to make it equilibrium are not concurrent, because friction is this direction, this friction is this. These two forces are non-concurrent. They both are not passing through CG of it. समझा है? It means that we have to draw this B as a block itself. Now see what are the forces. 30 डिग्री वही है. फिर इसका वेट मतलब 500 plus 300 we already know, but we will say R, because for A अगर B के ऊपर A का वेट है तो B उसको रिएक्शन दे रहा है which is R. उनको पता है कि 300 है, लेकिन अभी उसको वही टर्म में लिख रहे हैं just to make it clear. This is one. Then this friction, so this wants to move this side, friction will be in this direction, that will be वो आ गया ना, यहाँ इधर आएगा ना फ्रिक्शन, इट विल बी इन दिस डायरेक्शन. फ्रिक्शन या reaction of B which will be 500 plus R है. खबर है अपन अजी जो और कोई फोर्सेस बचे हैं अभी, इनको बैलेंस करना है. સિસ્ટમ ઇક્વિલિબ્રિયમમાં છે એવું આપણને કીધેલું છે. કેમ? એટલે સમજો નહીં. What is your question? P फोर्स से, हाँ. He is asking that when P force is acting in this direction, then to resist P or to counter P, you need some force in this direction, which is true, which is provided by these components. આ બેનું રિઝોલ્યુશન કદાચ આમ આવે કઈ એક તો છે. अगर ये नहीं समझता तो मैं तुम्हें ऊपर बुलाता, 3 और लोगों को बुलाता और अलग अलग डायरेक्शन से हम खींचते और देखते कि वो बॉडी तो वहीं का वही है. It means that forces acting in their respective direction are balancing each other by keeping their direction. क्योंकि ये अगर फ्रिक्शन है तो यही डायरेक्शन में लगेगा, but it value of friction will depend on this. So this actual question of this is not to draw free body diagram, but to see that up to which force P this body doesn't move. तो प्रॉब्लम एक्चुअली ये है, कैलकुलेट P फोर्स दैट द बॉडी स्टार्ट्स मूविंग. इसका मतलब कि यू हैव टू जस्ट सी कि कितनी P की वैल्यू बढ़ाते जाए बढ़ाते जाए बढ़ाते जाए तब तक सिस्टम इक्विलिब्रियम में रहती है. दैट इज द क्वेश्चन. बट अगर हमें बोल दिया है कि सिस्टम इज इन इक्विलिब्रियम, then it is in equilibrium and we have to calculate the forces. We have to see how it is balancing each other. હજી કોઈ ડાઉટ? તારો કોઈ ભાઈ બી આ કોલેજમાં ભણી ગયો સિનિયર? Similar faces are repeating in 2-3 years. God has stopped making creativity. Same faces are coming. જોઈ લો એકવાર, કઈ ડાઉટ છે તને? You can ask silly questions also, no problem. But if you ask, then you will also realize કે મને આટલું સાદું નહોતી ખબર. Fine, ખબર પડી જશે. Then you can go for higher things. These are very simple things. It's not very difficult, but it requires typical type of attention. It doesn't require typical intellect. This doesn't require typical smartness or intellect, but this requires a typical attention, as same as mathematics. Clear? In book you can see many problems of free body diagram. You can conclude today. શું ટ્યુટોરિયલ બનાવ્યા નથી, ગયા વખતના છે, મારે બદલી કાઢવા છે. બહુ સિમ્પલ હતા. તમે લોકો હોશિયાર છો ને તો હું અઘરો આપવાનું છું. બૂમ પાડને શીટને. મેં ખરેખર જોયું તમારા, એટલે કમ્યુનિકેશન તમે અલગ જ કરો છો. તમારા દરેક કમ્યુનિકેશનમાં તમે થર્ડ પાર્ટી છો. કાલે બી મારે આને ટકોર કરવી પડેલી, આજે આને પણ. સર એટેન્ડન્સ શીટ નથી આવી, તો તું શું કરે છે? એટેન્ડન્સ શીટ નથી મળી, એમાં તમે છો અંદર. તમને સમજાય છે ડિફરન્સ કમ્યુનિકેશનનો? મને એટેન્ડન્સ શીટ નથી મળી અને સર એટેન્ડન્સ શીટ નથી આવી, તો હું પથ્થર છું કે મારી સુધી આવવાની છે? નથી મળીમાં તમે અંદર છો ઇન્વોલ્વ કે સર મને નથી મળી. તમે એવું નથી કે તમે નથી આવી. એટલે મને સમજાતું જ નથી કે કેમ એવું. નથી આવી એ ફેક્ટ છે કે નથી મળી એ ફેક્ટ છે? પેલો છોકરો ક્યાં ગયો? બગડેલી છે બેન્ચ વાળો, નથી આવ્યો. હવે એનાથી નથી હવાયું કે નથી આવ્યો? નથી આવ્યો. તો તમે એવું કહો સર એનાથી નથી હવાયું, એ આખી અલગ ઘટના છે. અને એ નથી આવ્યો એ આખી અલગ ઘટના છે. એટલે એટેન્ડન્સ શીટ નથી આવી એ અલગ ઘટના છે, અને એટેન્ડન્સ શીટ નથી મળી, અહીં નથી પહોંચી, એ અલગ ઘટના છે. બોલતા સાચવજો મારા ક્લાસમાં.